Good evening, viewers. Welcome to Eugene TV. I welcome you back again on track for our online lesson. Alright, please, I want to beg that if you have been following this channel, please always do well to like, comment, and share my videos so that it will get to a wider audience. We know so many persons who are aiming at writing different external examinations, ranging from WAEC that have just been concluded a few days ago, NECO that is forthcoming, JAM that is coming next year, and of course post-UTM. Please, whenever you come across any of my videos, please do well to share, like, and comment. Thank you. Okay, let us look at the question that is before us, and of course this question is based on electrolysis. Okay, the question says, what is the mass of silver that will be produced where the current of 6.5 ampere is passed through a solution of silver triisonitrate 5 for 1 hour 30 seconds. Atomic mass of silver is 108, and of course 1 Faraday equal to 96500 coulomb. So we have the following option here. There is a mix up here. Following option, I think 26.0 gram here. Okay. Have the following options here. 26.0 gram, 2.0, 4.0, 100 gram, and 108 gram. Please, this is not the first time we are making video on that is based on electrolysis. The subject matter of electrolysis is so wide and questions can be asked in different ways. So we do well to explore different ways in which questions can be expected or can be asked in any of the external examination. And of course, this one is going to be based on mass, calculating the mass of a substance that is deposited. This question is just simply based on Faraday's first laws of electrolysis. Now we are going to establish two things before we go into answering the question. And of course, I want to let you know that this question is going to be answered in two ways. It is very, very simple. Whenever you come across any question like this, please don't panic. I am going to show you the step-by-step, simple step-by-step method that you can use to champion such a question. Alright, so first we are going to establish again, because me, I like bringing out definitions. Because it is said that anything you cannot define, that means you cannot refine that thing. So we'll start from definition. What is electrolysis? Electrolysis, we have been saying, or we have said here before, that it can be defined as the chemical decomposition of a compound brought about by the passage of a direct current passing through a solution of that compound or its molten form. Alright? So again, of course, we have laws of electrolysis of first law and second law, and it is on first law of electrolysis that this question is based upon. First law of electrolysis, or Faraday's first law of electrolysis, states that the mass of substance deposited during electrolysis is directly proportional to the quantity of electricity that is passed through the electrolyte. Alright, so let's take a look at the question now. Whenever we see a question like this, please don't panic. Like I've said, I'm going to give us two methods or two ways we can solve this question. Okay, let's start off this way. We say solution. Alright, so we are first going to look at what is called quantity of electricity. And of course, according to Faraday's first law of electrolysis, quantity of electricity is given as current times time. Q here stands for quantity of electricity. I stand for current, which is usually in ampere. YT here stands for time, which is usually supposed to be in seconds. Alright, let us find our quantity of electricity first. So we are giving current to be 6.5 ampere. From the equation, current was given to be 6.5 ampere. Alright, our time, we were giving time to be 1 hour 30 seconds. So whenever you are giving time in hours or in any other unit, we are supposed to convert such to seconds. So how do we convert 1 hour 30 seconds to seconds? First, let's begin with 1 hour. Remember, we know that 60 seconds is equal to 1 minute. 1 minute. But first, have it in the back of your mind that 60 minutes will be equal to 1 hour. So that simply means that 1 hour is the same thing as 60 minutes if it is going to be in the unit of minutes or a minute. Alright, so how many seconds here is going to make 60 minutes? And of course, we know that 60 minutes is the same thing as 1 hour. Let me say that again. We already know that 60 seconds is equal to 1 minute. Now, how many seconds are going to be there in 60 minutes, which is equivalent to 1 hour? Alright, so we cross multiply. If we don't know, we'll make a subject formula x. So we cross multiply 60 times 60. Okay, 60 times 60 divided by 60, sorry, divided by 1 is going to second is equal to 1 hour. Remember, the question says 1 hour, 30 seconds. So we are going to add the 30 seconds to it. And of course, this is going to give us 3,630 seconds. So this is our time. It is this time we are going to use to solve the problem, not the 1 hour, 30 seconds. Alright, so we now calculate our Q, quantity of electricity current, is equal to 6.5 ampere, and of course our time is 3630. Alright, so this is going to give us let's say 6.5 times 3630. Okay, this is going to give us 23,955. Sorry, 559. 595, I mean, 95 coulomb. This is our quantity of electricity from the equation. So we know that, okay, let me erase here and come over here. So what we are finding here is just the quantity of electricity. We know that if you have the electrolysis of silver triazonitrate AgNO3 aqueous. During the electrolysis, this compound or this salt solution is going to ionize to form silver ion and triazonitrate ion, all in solution. Okay, our concern is about silver, not the triazonitrate ion. Alright? So, during electrolysis, according to ionic theory, the silver ion will migrate to the cathode. So, where it will go there to go and acquire electrons. Usually, in electrolysis or in an electrolytic field, the cations will usually migrate to the cathodes, which is negatively charged. And of course, whenever the cations go there, they go there to gain electron or to accept electron. Alright, so if you have silver ion like this that will migrate to the cathode, it will go there and accept electron so that it become reduced to neutral silver atom. Alright, usually if a cation or if an ion migrates to any electron, it is always going there to accept electron, to gain electron that is equal to the number of charge that ion is carrying. Silver has a charge of +1. So if it migrates to the cathode, usually it will go there and acquire or gain 1 electron, which of course will make it to become reduced to silver atom. Alright? So we already know that the quantity of electricity that is needed or required to discharge or liberate 1 mole of electron is 96500. 96500. Alright, this 96500 will discharge or will produce 1 mole of silver. And of course, the mass of 1 mole of silver was given to be 108 grams. Now, if 96500 column will discharge 1 mole of silver, which is equal to 108 grams, how about the quantity of electricity we have calculated from the equation, which is 595 column? What is going to be the mass that is going to be produced? So we say with x, we don't know. We make x subject of formula and we cross multiply. We multiply this side, 23,595 times 108, all of 96500. 96500. Okay, let us see. Okay, then we divide by 96500. So we are going to obtain mass of 26.40. Okay, I think this should be approximately 26.0 grams. So the answer is 26.0 grams approximately. So you can see from our working here, from our calculation here, the correct option is option letter A. Option letter A is the correct answer. So the mass of silver metal that will be produced when a current of 6.5 ampere is passed through a solution of silver triazonitrate for 1 hour 30 seconds is going to be 26.0 grams. Now, like I said before, I want to use another method. Of course, this one is going to be formula method. It's very fast, but we need to understand something. So, permit me to erase this. Let me erase this and use the formula method If you don't want to waste your time in going through this long process, just apply the formula method. Very simple and fast. The formula is this: small m all over capital M is equal to Q all over C times F. Alright, now I will not waste time. Now, this small m here means mass. Mass of substance, usually in gram. In gram. Okay. Then the capital M there is the molar mass. Is the molar mass or atomic mass. Atomic mass. The atomic mass of the element. Okay. So Q, we know, is going to be quantity of electricity. Quantity of electricity. That is the meaning of the Q there. While C is a charge. Is a charge of the ion. The charge. Of course, our F is our Faraday. F is Faraday. So in this our equation or formula, small letter m here stands for mass of the element, which is usually in gram. The capital M here is molar mass or the atomic mass. It is usually given, right? Or you will be made to find. Q here stands for quantity of electricity. Remember, quantity of electricity is equal to IT, so we can as well replace this Q with IT. The C there is a charge or valency of the ion equation. Then F stands for our Faraday. So let us see how we can use this formula to answer this question very fast. Alright, so our mass here is what we are looking for, we don't know. The molar mass or atomic mass of silver is 108 is equal to Q. Quantity of electricity we calculated before, I cleaned it. This is the quantity of electricity we calculated from the equation. This was the quantity, which is 23,595. 595. Then the charge of silver is 1. And then the value of 1 Faraday is 96500. So it's just for us to make M our subject of formula. If we make M subject of formula, we cross multiply. So M is going to be 108 times 23595. Then divide by this. Okay. So let me come this way. Let us cross multiply. M times this is going to give us 96500 M is equal to 108 times 23,595. So we can divide both sides of the equation by 96500. 96500. So this 96500 will cancel 9. So our M is going to be okay, the answer is going to be 26.40. Approximately, this is going to be equal to 26.0 grams. The same thing. So whichever way or whichever method you choose to, you are still going to arrive at the same answer. This further confirms that the correct option or the correct answer is option letter A. Please, if you have any problem on how to perform calculation on Faraday's law of electrolysis, please give me a DM. Follow my videos on my YouTube channel, Eugene TV. You can also follow me live on TikTok, Eugene TV 101 on Facebook.